Right now, somewhere on a coast in Florida, there is a 70-ton tube of metal. It is bolted to the ground. It is filled with the most violently flammable liquid we know how to handle, and in about 10 minutes, it is going to set itself on fire on purpose and use that fire to climb out of the sky. We call this a rocket. And here's what's wild. A rocket does not actually fight gravity. A rocket does not really know what gravity is. A rocket does one boring thing. It throws things out the back really, really hard. Today, like you are 5, here is how humans figured out to ride a controlled explosion all the way to another world. Buckle in. First, how does a rocket move at all? The answer is the same trick a balloon does. Squeeze the neck of a balloon, let it go, and the balloon flies across the room, pulled by absolutely nothing. There is no string. There is no fan. The balloon is flying because of one of the deepest rules in the universe. If you throw something one way, you get pushed the other way. Always. Every time. No exceptions. A balloon throws air out the back. A swimmer throws water out the back. A rocket throws burning gas out the back. The bigger and faster the thing you throw, the harder you get pushed forward. That is it. That is the entire principle of every rocket ever built. From the Chinese fireworks in the year 1200 to the Saturn V, the rocket that took humans to the moon, every single one is just throwing stuff backward as hard as physically possible. So why doesn't your car work like that? Why can't we just put a giant fan on a car? The answer is, your car is using the ground. Wheels grip the road. Roads exist. The ground exists. There is something to push against. In space, there is no ground. There is no air. There is no road. There is no anything. The only thing a rocket can push against is the stuff it brought with it. This is why a rocket is mostly fuel. Not mostly engine. Not mostly metal. Mostly fuel. Look at any picture of a rocket. The skinny little capsule at the top, that is the part people ride in. The rest, that gigantic tube underneath it, that is fuel. Just fuel. A rocket, the size of a tall building, is, roughly speaking, a giant gas tank with a tiny phone booth glued on top. Here's the part that breaks your brain. Rockets need to throw stuff backward, fast. But the faster you want to go, the more stuff you need to throw. But more stuff means more weight. But more weight means you need to throw even more stuff. We call this the tyranny of the rocket equation. The math says that to launch 1 kilogram of astronaut into space, you need to launch about 50 kilograms of fuel and machine. Almost everything in a rocket exists to launch a tiny bit of stuff that exists to launch a tiny bit of stuff that exists to launch you. Which is why we invented multi-stage rockets. The idea is brutal and brilliant. Burn your bottom tank, then throw the entire bottom tank away, like a soda can. Now your rocket is lighter. Burn the next tank, throw that away too. By the time your rocket reaches the top of the sky, you have left a trail of empty fuel tanks across the ocean. The thing that arrives in orbit is a tiny fraction of the thing that lifted off. The Saturn V, the most powerful rocket ever flown, burned through about 20 tons of fuel every single second, 20 tons per second, the same weight as 4 full-grown elephants, incinerated every second for 2.5 minutes just to lift its own bottom stage. It was, briefly, the loudest machine humans had ever built. People watching the launch from miles away said it felt like the air itself was being torn. So, you build this absurd, fuel-eating, multi-stage tower of explosions, and then you point it at the moon, which brings us to the second wild part of this story. In July 1969, 3 Americans climbed into a capsule about the size of a small car, sat on top of one of these monsters, and flew to the moon. They did it with less computing power than the microwave you use to reheat leftovers. They did it with slide rules. They did it with calculators that you could throw out a window today, and nobody would miss them. And it worked. The mission was called Apollo 11. The 3 astronauts were Neil Armstrong, Buzz Aldrin, and Michael Collins. 2 of them, Armstrong and Aldrin, would land on the moon. Collins would stay in orbit, alone, the most isolated human being who has ever lived, while his friends went down to the surface. The journey took 3 days. 3 days just to get there. The moon is about 250,000 miles away. That is roughly the distance you would drive if you drove around the Earth 10 times in a row, and they did it in a vehicle the size of a delivery van, sitting on top of a fuel tank the size of a skyscraper. When they got there, They did not just glide down. The Saturn V got them to the moon, but landing on the moon required a completely separate, smaller rocket called the lunar module. It looked like a spider. It was made of foil so thin you could put your finger through it. There was no room to sit. There were no windows in the floor. Armstrong had to land by looking out a small triangular window, manually steering this spider-shaped tin can onto the surface of another world with 60 seconds of fuel left. He landed, he stepped out, he said the words, and then they hopped around in low gravity for a few hours, collected some rocks, planted a flag, and got back in the spider and flew up to meet Collins. The whole stay on the surface was about 21 hours. 21 hours. After 2,000 years of looking up at the moon and wondering, humans were there for less than a day on their first trip, and we went back 5 more times. 12 humans have walked on another world. Ever. Total. In all of history. The last one was in 1972. Eugene Cernan. He climbed up the ladder into the lunar module, and the next foot to touch the moon was over 50 years later. The Apollo program ended. The budgets got cut. The country moved on. And the moon, the closest world to our own, became a place we knew we could reach, but stopped reaching for. But we are going back. The program is called Artemis, named after Apollo's sister in Greek mythology. The plan is to put humans back on the moon this decade, and this time, to stay, to build a base, to use it as a launching pad for Mars, to make humans, finally, a multi-world species. The next time you see a rocket launch on a screen, here is what to remember. You are watching a controlled explosion. You are watching a fuel tank with a tiny phone booth strapped on. You are watching a multi-stage absurdity that exists because of one simple rule. Throw something one way, you get pushed the other. And the next time you look up at the moon, here is the wild thing. 12 humans in your own grandparents' lifetime stood there and looked back at the Earth. They saw it as a small blue marble hanging in black space. They breathed inside a metal can. They drove a buggy. They left footprints that are still up there right now because there is no wind on the moon to blow them away. The exact spot Neil Armstrong stepped is exactly the same as the moment he stepped right now, today. It happened. Humans did it with slide rules and grit and a rocket that ate elephants for breakfast. Hit the channel for one wild thing every week, explained like you are 5.